So the last few days in class, I've been talking about the periodic table and how using the periodic table, you can look at atomic number to figure out the number of protons, or if you want to know neutrons, you can take the mass number minus the atomic number. But while we've been doing that, we also realized that your masses from the periodic table don't necessarily match the mass number that you're given in a problem. And the reason for that is that the masses on your periodic table are averages, specifically weighted averages of all the different isotopes. And what we're going to look at here is how these averages or weighted averages are actually calculated. So if we look at boron as an example, boron has two different isotopes. It can be boron 10 or boron 11. And we're given the mass of each of those isotopes as well as how common they are. When we're figuring out a weighted average, it's not as simple as just add the two together and divide by 2, because these two isotopes shouldn't be treated equally. Boron 11 is much more common and it should be weighted that way. So what you do to calculate your average atomic mass is you take the mass of the isotope times abundance. And abundance has to be changed to a decimal. And you're going to do that for each of your isotopes, and then you're going to add them together. So if we look at this, for example, boron 10 has a mass of 10.0130 AMU and an abundance of 19.9%. To go to a percent, from percent to decimal, you're going to move decimal 2 spots to the left. So if I want to move this decimal 2 spots to the left, I get 0.199. If you're given the rounded mass and the more exact mass, you're always going to want to use the more exact number. We're going to do the same thing for the other isotope, 11.0093 times 80.1, move our decimal 2 spots to the right, 0.801. And we're going to add these together. So if I do the math, I get 1.992587 and 8.818. When I add them together, I get an average of 10.81 AMU, which would be my answer. It's always a good idea to look at, does my answer make sense? I'm averaging 10 and 11. I should end up somewhere between those, which 10.8 makes sense. If we look at another example, it says neon has 3 isotopes. 90.51% of neon atoms have a mass of 19.992 AMU. 0.27% are 20.994, and 9.22% are 21.991. So we're going to do the same thing. We're going to take our mass, 19.992, times our percentage, move 2 spots to the left to 0.9051, 20.994 times, still got to move 2 spots to the left, 0.0027, and 21.991 times 0.0922. And then we got to add. When we do the math, we get 18.0947, 0.0566838, and 2.0276. So we add these together, we end up with 20.18 AMU is our average atomic mass. Again, we're averaging 20, 21, and 22. We get an average of 20.18, so that makes sense.